This is an A-level core pure question, and this is complex numbers and solving geometric problems. In an Argand diagram, the points A, B, and C are the vertices of an equilateral triangle, with its center at the origin. The point A represents the complex number 6 plus 2i. Part A, find the complex numbers represented by the points B and C, giving your answers in the form x plus iy, where x and y are real and exact. Okay, so for this part of the question, there are different methods I can use. I can change the complex number into exponential form and use that to find the other vertices. I can change it into modulus argument form and do that, or I can use a rotation matrix to find the other vertices. I'm going to do the third one and use a rotation matrix. So the way that works is that if these are the vertices of my equilateral triangle which centers on the origin, then basically each one of those vertices is, I can take one of those vertices and rotate it round clockwise or anti-clockwise by 120 degrees, which is the same as 2 pi over 3, and that will give me what the other vertices are. So that's 2 pi over 3, or if you want to work in degrees, 120 degrees. So let's write down what the rotation matrix is. So it's cos theta minus sine theta, cos theta, and we just need to remember that theta is the angle of rotation and it's the anti-clockwise angle of rotation. So we just need to be aware of that. Okay, so I'm going to take my point 62 and rotate it by 2 pi over 3 anti-clockwise. I could also do 2 pi over 3 clockwise, but I'd need to change the angle. So cos 2 pi over 3 minus sine 2 pi over 3, sine 2 pi over 3, and then cos 2 pi over 3. Multiply that by the point 62. So first of all, I'm going to write down what these values are. So cos 2 pi over 3 is minus a half, so I'll put minus a half here and minus a half here. And sine 2 pi over 3 is root 3 over 2. So over here we're going to have negative root 3 over 2, which we're going to multiply by the 0.62, and then that will give us one of the other vertices. Right, so let's multiply this out. So negative a half times by 6, that's minus 3. And then minus root 3 over 2 times by 2, so minus root 3. And then for the bottom down here, root 3 over 2 times by 6 is going to be 3 root 3. And then we're going to do negative a half times by 2, so minus 1. Right, so let's write that root down. So we have negative 3 minus root 3, and then plus 3 root 3 minus 1i. Okay, so let's highlight that. And what we're going to do now is rotate the original point again, but now by 4 pi over 3. So I should get the other vertex. So I'm going to keep this working here and just replace this 2 pi over 3 with 4 pi over 3. Okay, so here we go. So let's work out the exact value. So the cos of 4 pi over 3 is negative a half. So that's going to go here and here. And the sine of 4 pi over 3 is negative root 3 over 2. So this element up here, because it's a negative, will then become positive root 3 over 2. So let's multiply this out. So this times this is going to give me minus 3. And then this times this is just going to give me plus root 3. And then at the bottom, multiply these two together. That's going to give me minus 3 root 3. And then times these two together, it's going to give me minus 1. So I've now got my other vertex, which is minus 3 plus root 3, and then plus negative 3 root 3 minus 1 I. And let's just highlight that, and then we'll move on to part B. Part B. The points D, E and F are the midpoints of the sides of triangle ABC. So that's going to be, let's mark those on. So point here, and a point here. And part B, find the exact area of triangle DEF. So that's going to be a triangle that looks like this. Yeah, we want to find the exact value of that area. Now, one of the properties of equilateral triangle and its midpoints join to form another equilateral triangle is that the area of this is a quarter of the area of the larger triangle. So I'm going to use that property to find the area of this triangle here, which I'll shade in green, by working out the area of the larger triangle and then dividing that by 4. Right, so let's write down that the area of triangle DEF is equal to a quarter the area of triangle ABC. And to find the area of triangle ABC, I'm going to be using half AB sine C. That's because I know this angle here is going to be 60 degrees or pi over 3. I just need to work out the length of a side, and they're all going to be the same. And I can work out the length of a side by working out the distance between two vertices by using Pythagoras. And I'm going to use these two vertices here. So I'm going to find the distance between the vertices B and C, because I think it's actually easier to find the difference between these values than it is 6 and 2 and these values. Okay, so it's going to be the square root of, so let's start by working out the difference between these two. So we've got minus 3 plus root 3 to minus 3 minus root 3. Okay, so let's start with these two. So the difference between them is 2 root 3. So if I added 2 root 3 to this, I'd get this. So it's going to be 2 root 3 squared. Right, what's the difference between these two? Well, there's a difference of 6 root 3. If I add 6 root 3 to this, I get this. So it's 6 root 3 squared. That's a little bit easier, I think. Now we'll work that out, and that gives us 2 root 30. So the area of this triangle DEF is a quarter of the area of ABC, and that's going to be half A, which is the 2 root 30. That's the length of the side, 2 root 30, times by the other side, so times by 2 root 30 again, times by the sine of the angle between them, that's this 60 degrees, which is pi over 3. And that gives us exactly 15 root 3 over 2. And there's our exact area. This is one way of doing it. There are other ways of calculating the area.